The last diagnostic we will talk about is outliers. So these are the real outliers that have large residuals, right? Large in absolute value. To judge what is large, we need to standardize the residuals just as we have done before. So we know the residuals by assumption follow a normal distribution. If we want to judge what is large, it is better to standardize them. And so we know that the estimate residuals have the standard error where there is H in here, so part of the head matrix, so the leverage. So standardizing gives us this expression, and then we have a normal distribution, normal 0, 1. And this allows us to know what large is, because for a normal distribution, we know that about 5 in every 100 observations should be larger than 1.96. But 1.96 is hard to see on a graph. We're talking 2 here, right? So about 5 of 100 should be larger than 2. And only about 3 of 1,000 should be larger than 3. So there is one minor technical issue here. It's minor. The standard errors were estimated using all observations. Now, if the value that you're interested in is an outlier, then it's going to have a large residual, and the estimate of sigma will be inflated. So technically speaking, what you have to do is you do the exact same thing. You standardize the residuals, but you do everything leaving out the ith observation. This will avoid inflating the sigma. And those residuals are called the studentized residuals. All right, so if we find studentized residuals that are greater than 3, then we want to raise some eyebrows and think about it. Of course, this could happen, right? If you have 1,000 observations, it should happen 3 times. Now, if you have values greater than 4, we're looking at criminal observations here, so that is not happening. It is possible to plot this as a diagnostic, so studentized residuals versus fitted values, and instead of plotting versus fitted values, you could plot it versus an index, whatever helps you in the context of the problem. Now, what happens if you actually find an outlier? Well, this is your great chance to be detective and talk to the data collectors and see what's going on. This can actually be really, really rewarding. You learn a lot about the data, and that often helps you in the further analysis and everything else that you do with the data. If you find an error, of course, you correct them, such as typos. If the values are all correct, then you have to see whether they affect conclusions. So you take them out, redo everything, and see whether you get different results. This is very time consuming. That's the big disadvantage of diagnostics. But in the end, when you reach a conclusion about your data set, no conclusion should be made that depends just on a couple of outliers. So if the outliers change everything, you're gonna have to take them out, even if you have no explanation of what they mean. All right, that brings us to the end of diagnostics. Well, we'll see some examples, but the end of the different diagnostic plots.